Okay. Good morning, all. Am I audible? And PDF is visible. You can use the chat box to reply. Am I audible to everyone? Okay. Okay. Let's start the session. So in the last session, we had discussed about the regression modeling. So let us go brief introduction simply of regression modeling. Okay. So basically, regression is a mathematical formulation derived between the variables. Okay. So and why we do the regression modeling? So that we can provide some estimation, some prediction based on our data set. We had discussed one example. In that example, we had discussed about the weight of individual person, and that weight is directly dependent on the height, diet, and workout. So we can see that if we are changing the value of height, diet, and workout, it is affecting the value of weight of that particular individual. So we have defined weight as a predicted variable, and all other variable which is responsible on the predicted variable is called predictor variable. So here height, diet, and workout is the are a predictor. So then we had discussed about predicted variable is a dependent variable, and predictor variables are called independent variables. Next, in regression, we have to find out at what extent the predicted variable is affected by the prediction. So, if we are able to find out the relation between the predicted variable and the predictor, and what extent that relationship is hold, that is a part of the regression. Amount of variation in predictor will result in variation in predicted. So, suppose we are varying the predictor variables like height, height and workout. So you can find out that predicted variable will also vary based on those elements. So suppose I have changed some person height, diet, and workout two times, then definitely his weight will be affected at that particular relation. Okay, the predicted variable in mathematically represented by y and predicted variable represented by x1 and x2x. Then we had discussed about that selecting a suitable predicted variable, acceptable measurement quantities are required for process for performing regression analysis. When we are having a single predictor, as we have discussed about that, your if you are designing pocket expense predictor for you, then it is only depends on the pocket money you are receiving from your parents. If the money is increasing, your pocket expense will be increased. If the money will be decreased, it will directly reflect to your pocket expense predictor. And if we are having more than one predictor, then it is called multivariate analysis. So in a multivariate analysis, we had discussed that if we are predicting a house price prediction, house expenses prediction, then you can find out that uh, your house price expenses predicted is depend on not only the source of the income of the house, it also depend on the various factors. So it is here predictor variables are more than the source income. It can be your expenses, it can be some emergencies, it can be some festival seasons and so on. So based on that, it can be weekend, it can be weekdays, it can be a picnic. So various factors are there that is responsible here in multivariate analysis. We have to collect sufficient number of data points, and we have to use a suitable estimation technique to arrive at a mathematical formula. So here, suitable estimation technique means we can apply the machine learning approaches. We can apply the various estimation algorithm to predict the relationship between the predicted and predicted values. Then we have discussed about that no model is perfect, so hence give error bounds is necessary. So you have to make some assumption for the error because no model is perfect. So you have to make sure that what type of error you are going to consider for your model. Assess the model stability by applying to different samples. So if we are have created our model for our own house, then we have to find out the stability of the model by uh, taking the data from other houses from locality and apply to our own model. If our model is providing a same accuracy result, then we are can say that our model is stable. Now, when we are sure that our model is stable and it is providing an accurate result, now we can apply the predictor variables for a new data point. So we can take any random data point from a we can take any random data point from any other location, and based on that data point we can perform the estimation based on those data points. So suppose we have applied house expense prediction model for own locality. Now we can, if we have trained the model, if we have validated the model, then we can apply the model to a new locality on the new data. We have to perform the model cross validation for uh, checking the accuracy of the model. Then we have discussed about least square method. So in least square method, we find out the square errors between the observed variable and target variable. So you can see that here our target variable, actual variable is this, and observed variable is this. Okay, our actual variable is this, and observed variable is this. So there is a difference between the actual variable and our. Uh, so you can find out that based on this data, we find out the square of error, and we are trying to minimize the square of error at a minimum level. Okay, the error is defined as the difference between observed variable and predicted variables. You can find out that there is some difference between the observed value and predicted value, and based on the difference, we call that error. Now we have to take the square of error, that is the forward of this square. The objective of regression estimation is produce least squared error as a result. When error approaches zero, determine accuracy. So our task is here to minimize the square error to zero as much as possible. And if you are able to find out a zero, then it is a overfitting model. So sometimes in real scenario it is not possible. So what we are trying to do, we are trying to minimize the error between the observed value and the predicted value. Okay. Now, least square method provide linear equation with unknown that can be solved for any given number. So when you are applying the least square method between observed value and the predicted variable value, it will provide a linear equation. The relationship between in the form of a linear relationship and with unknown that can be solved for anything. And the values which are unknown to each other, that is called regression parameters. Linear equation are called as a normal equation, so we can also call it a normal equation. And normal equation derive using calculus to minimize square. So now we'll apply the calculus concept to minimize the square error between the observed and predicted. So, apart from regression modeling, there are other algorithms which can attempt to minimize the square error unless the objective state achieved. So, these algorithms are artificial neural network and GLBITM. So, there are also other algorithms. You can refer the Wikipedia for regression modeling. I have also provided the reference link which I have taken to prepare this note at the end of this PDF, and you can refer those link and for the further instructions. Okay, so we had covered the regression analysis. Now we go for the multivariate analysis. So as previously we had discussed that regression analysis, when there is a one predicted variable and a one predicted variable, we call it a bivariate analysis. But when there are more than one predicted variable, then we call it a multivariate analysis. So, for example, we had discussed about the house expenses prediction. So, expenses prediction is a predicted variable, and it is depends on the various variables. So, we call that a predicted variables. So, it is not possible that your house expense prediction will depend on only one variable. But when we minimize the problem to your personal expense prediction, so you can find out that it is solely depend on the pocket money you are receiving from the car. So that is a bivariate analysis problem, and this is one the multivariate analysis. So multivariate analysis based on the principle of multivariate statistics. Okay, so we have to find out the relationship between the multiple predicted and predicted variables, and what are the relationships we have to analyze using the statistics. It involves observation and analysis of more than one statistics outcome variable at a time. So, in a multivariate analysis, it is also possible that we are having more than one predicted variable and more than one predicted variable. So, we have to apply the statistical approaches to find out the relationship between the output variable and the predicted variable. It is used to address a situation where multiple measurements are made on each experimental unit. So when we are having a different situation, for example, when we are designing a model for house expenses prediction, you can find out one situation where you are having a festival environment. Are you having a weekend planning? So in that scenario, your house expenses prediction is mostly affected by the festival season. So you are more spending, uh, and it is not directly related to the income source of your house. And another point can be that if there is a no festival season or no event happening around the year, then your house expenses prediction is depend on the income source of the money and your daily day-to-day need of the house. So in this multivariate analysis, we try to find out the relationship between these measurement and the structure of the important parameter. So we are trying to find out that what is the relationship between the different situations. For example, what is the relationship between the variable when there is a festive season and where there is a no festive season in the setup. Uh, let us discuss about the financial instrument. So, in a financial instrument, you can find out that we have to be more focused about the various factors that is affecting the finances of the personal, finances of the individuals, and the finances of the countries and finances of the businesses. So, a relationship between the various characteristics of the instruments are. So when we are trying to find out the relationship between the various financial instruments, so what is a financial instrument? Financial instruments are the way where we are managing our money. So for example, You are having a bank saving account, that is the one financial instrument. You are having your personal saving space at your home, that is the one financial instrument. Some of your money is being invested into some bonds by government, that is the one financial instrument. If you have taken some loan for your house or your personal expenses or any education loan, or you have taken a mortgage loan, or you have taken any uh, a specific loan, credit card loan. So these all comes under the financial instrument. Now you have to find out the relationship between these instruments based on their characteristics. So it is also possible that if you have taken a credit card loan, uh, your house expenses prediction model is somewhat dependent on the credit card. So how is it related to that credit card loan that is a part of the practical? Same way, suppose you're having a house and now you have uh, purchased a house and you have taken a loan from the bank. So based on the land loan, you can find out that that is your compulsive investment, and you have to make sure that every tenure of your loan you have to submit the loan to the bank. But you can directly manipulate the credit card loan. You can, if you are having a surplus money, you can opt for more purchasing on the credit card. If you are having a low money, you can opt for less purchasing of credit card. But the financial instrument like your housing loan is not uh, affected by your changing houses expenses. It is a fixed type of instrument. So when you find out that you are bound to 20 to 30 years of relationship between your house loan, but your credit card loan is generally lost for 1 or 2 months. So we have to find out, analyze this financial instrument. If you talk about the biopharmaceutical medicines, though, then you can find out the principal patients multiple response to a drug need to be related to the various measures of toxicity. So it is not necessary that a particular drug, if it is treating a cancer patient, will have a same effect of all the cancer patient with a similar symptoms. Maybe some drugs are good for some patient and they are giving a more uh, favorable result. But compared to other patients, they are not very favorable. They are giving a worse performance, or they are very performing very badly for other patients. And we have also measured that what is the measure of toxicity among the patient for any drug related to any drug. So you can find out that here the relationship is more complex. So if you are having a predictor variable that is a drug, and it's all the combination of the drugs, and again you can go into deep and trying to find out the quantity of drug and the taking prescription pattern of the drugs to the patient, and your predicted variable can be outcome of if outcome and effect of the drug on the patient, and you can also measure the toxicity of that. So if you are trying to find the relationship between that, that is a complex. Some of what falls into the rubrics of multivariate analysis, parallel, traditional, univariate. So, for example, hypothesis says that compare multiple population. So, suppose you want to compare population of different countries or population of different regions, population of different locality. So, you have to find out the some relationship between those populations variables and the predictor and predicted variables. Larger part of multivariate analysis is unique to it. For example, measure the strength of relationship among various measurements. So you can find out that uh, when we are trying to measure the relationship between various measurements. So suppose you have applied a way to analyze the drug effect on a patient. You have applied a way to compare the population among different regions. Now, if what type of approaches you have applied, you can measure the effect of those approaches, which approach is better compared to other approaches, and so on. So, or you can also create a relationship. Now, next. Uh, Multivariate analysis, due to the size and complexity of the underlying data set, requires much computational effort. So you can see that when we are having a data set in a few MB size, then you can find out it is very easier for your personal system to perform some operation on the data set, which is in the size of M. But when the size of the data set is growing in exponential fashion, for example, if you are dealing with a data set which is in a 1 TBs, then your personal system is not able to perform those operations of that. Again, you have to require some more computation power. You have to apply some complex algorithm or complex approaches to find out the relationship between the predictor variable and predicted variables. Now you have these all result into the more computation. Uh, as you can see that in recent decade, you have seen that our personal system as well as our computational system has give, gained too much power, computational power in the last decade. So this growth of computational power, this growth of performing more operation on data in a less in a more faster way will created increasing important role for multivariate analysis of in for data analysis and multivariate techniques. Now let us discuss about the categories of multivariate analysis. So, categories of multivariate analysis can be normal and general multivariate model and distributed theory. So, you can have a normal multivariate analysis. You can create a more abstract multivariate model which can be applied to multiple problems, or it can deal with the multiple domain of the same problem, and you can also apply the distributed. Second category is the study and measurement of relationship. Suppose you want to measure the relationship between the predicted variable and predicted variable for different type of problems. So definitely that relationship will differ. And if you are trying to find out the relationship between the predicted and predicted variable on a same problem but in a different situations, then that particular relationship also differ. So if you're trying to measurement the relationship between these predicted and predicted variable, and we are trying to propose some analysis on that, that is also a category of multivariate analysis. Probability computation of multidimensional regions. So, suppose you want to perform the probability operation or various multi-dimensional problems. For example, when we are dealing with drug disease problem, drug disease, then you can find out that drug and disease relationship can be a multi-dimensional relationship. So, a drug can have a and dimensional effect parameter that will affect the diseases in m-dimensional. So you can find out that it is a multi-dimensional relationship between the computational operator variable and the exploration of data structure and pattern. So it is also important. Suppose you have a data set which is you have collected from an e-commerce website. Then you can find out that that particular data set have a different hidden data structure and pattern inside it. Now it is a task of the data analysis team to find out that hidden data structure and pattern. For example, if you're having data related to the mobile selling platform or mobile selling devices, then you can find out that uh, if we are taking this data uh, in context of various stakeholders, so every stakeholder will having a different view on that data. So based on that view, based on that perception, the hidden pattern inside the data can be varied for different stakeholders. So we also had discussed about this problem in our last sessions. Now, multivariate analysis includes many statistical methods that are designed to allow inform multiple variables and examine the contribution. So you can apply the very statistical approaches to deal with the multivariate analysis problem. These variables are predicted variable, or dependent variable, or predicted variable. So we had also discussed about this multivariate analysis. We have taken this figure from skillsneed.com. You can see inside the figure that your predicted variable 1, predicted variable 2 is also providing a predicted variable. So we can also call the predicted variable as a dependent variable because it is dependent on the various predicted variables. So uh, let us discuss before discussing an example of multivariate analysis. I want to please give me the example of multivariate analysis. So just take 2 minutes of time and trying to think about your day-to-day routine and day-to-day problems, and trying to find out any problem that is having that can be solved using the multivariate analysis approaches. Okay, so you have 2 minutes, and I'm expecting at least 2 to 4 response from your side. Example of multivariate analysis. So basically, what we are trying to find out problem which can be solved using the multivariate analysis. Okay. Till then, if you have any question, you can use the chat box, or you can unmute yourself and ask the question. Okay, please, guys. Response, please. Please refer the chat box for the problem, and I'm expecting at least 4 response from your side. There are I'm expecting at least 4 response. If you're having any problem to understand the multivariate analysis, we can repeat the that particular sentences from the video. Am I audible to everyone? You can if you're trying to find out problem in your locality, in your society, you can find out some problem which can be solved using the multivariate analysis. Basically, multivariate analysis is where we are having more than one predictor, and we can have more than one predicted variable. Guys, I will wait for 3 minutes more. 11:05 will start the session again. Please respond within 2 minutes. If you remember that we had already discussed about the house expenses prediction, that is a multivariate analysis problem. Your house price prediction. Okay, okay, very good. Sandeepan Devnath has responses. Very good. Laptop price is dependent variable. Processor is predictive variable. RAM is predictive variable. Okay, very good. Very good, Sandeep. Nice response. It is a day-to-day problem. Okay, Mr. Khan has replied. The doctor's letter on cholesterol, treatment of weight, related to eating habits and subject. She wants to use measures of health. Okay, very good. Okay, good. But doctor can be he also, he and she both. Okay. Uh, your prediction is a relationship between the measurement of health and eating habit. You can find out the relationship between the various variables. Very good problem. Okay, at least two more response. We have 1 minute left. Then we'll continue with the topic. Aditya, please response. Akshar, Verma, please response. Anushka, please response. Kavita, please response. Yati is present. Okay, Yati also responds. Is there any problem to understand the multivariate analysis? Okay, at least one more response, then we'll proceed with the lecture. Okay, so I think I'm expecting a response from. Okay, but let us proceed with the lecture. So let us discuss an example of multivariate analysis. Success at school, that is our example. So it is hard to measure success at school. Okay, Akshat Verma has responded. Okay, Sakshi has responded. Very good, very good. So good responses from your side. Very good, guys. Now let us discuss this problem: success at school. So it is hard to measure success at school. Why? Because it is a latent variable. Latent means a hidden variable. Means your success at a school can be defined in a various terms. So suppose student one is successful in some context, but student two is successful in some context and so on. So we might decide that success at school consists of academic success together with some measure of social success, perhaps every duration of friendship or size of friendship group, plus one of effort put in, which is to measure as a perception of either student or teacher. So it is a multivariate analysis problem to determine the success at school. So here success is not defined. You have, if you want to measure success, you have to measure in a various parameters. For example, you can measure it in a terms of academic success or social success. Now academic success and social success are dependent on the various predictors. So academic success can be dependent on your marks, your performance in Viva assessment, your classwork performance, your assignment submission, and social success is depend on your friendship, your size of friendship, your Facebook network, your social network, and so on. So you can find out that these are all object variables, and the measurement model examines the relationship between the object and the written data. So when we are trying to find out the relationship between the these academic success and social success, the marks to the social networking and so on. So we can say that it is uh, a problem of multivariate analysis. Okay, let us discuss some application of multivariate. So, guys, as we have discussed about the multivariate analysis, you can find out that there are various applications. For example, a multivariate hypothesis testing. So, what is hypothesis? We will discuss that. Basically, you can say that hypothesis is a relationship assumption between the variable. And if you have declared a relationship between some variable, now you have to test that particular relationship is validated on those variables. Dimensionality reduction. So suppose we are having an n-dimensional problem. Now it is very hard to compute that problem. So we can reduce the dimension of those problems from n dimension to the lesser dimensional space. So we that is also multivariate analysis. Latent structure discovery. So suppose we have a data set and inside the data set we are trying to find out the hidden structure, hidden patterns inside the data set. We can use the multivariate analysis. Clustering. For example, suppose you want to find out that uh, houses in a house market, some houses having a higher demand, some houses having a lower. So if we have a two types of category of the houses with a higher demand with a lower demand, we can define a clustering approach, or you can make a clustering problem here where the output is a houses with a higher demand, houses with a lower demand. Multivariate regression analysis, you can perform the regression analysis in the multivariate analysis problem, and it will provide you a estimation of the various output predicted variable. Classification and discrimination analysis, variable selection, multidimensional scaling, data mining. So these are some analysis, multivariate analysis problem. And these are some tools we have taken it from Wikipedia. And if you use those tools to perform the multivariate analysis problems, solution for the multivariate analysis problem. So one of them is a Python. So you can, if you are aware about the Python, you can perform the operation. If you are very good enough MATLAB, you can also provide the solution to the multivariate analysis problem. Bayesian modeling we'll discuss in the next. So again, my question is same to all of you. If you have any problem with the multivariate analysis, you can write in the chat box or you can unmute yourself and we can discuss about it. So basically, this lecture is a discussion lecture. It's not like that I will speak and you will listen. It is a discussion lecture, so please go on and trying to put out. Meanwhile, I have getting a response only from 4 students. So there are 29 students. I'm expecting a response from each and every student. And okay, so that is all for today lecture. And in the next 5 minutes, please provide your response inside the chat box. And I will mark the attendance based on the log record of Moodle. If you have access with link using the Moodle, your attendance will be automatically. And I will also upload the lecture on Moodle. So if you are accessing that lecture, it will also mark the attendance. Okay, so that's all for. Thank you guys for lecture. And now provide me the example of multivariate analysis problem as we have already given to you as a problem inside the chat box. Okay. We will open this session another 5 minutes. If you're having any problem, you can raise the problem. Now, please provide your response in the chat box. Only four students has provided the example of multivariate analysis. I think there are 30 students always 20 to 25 response per day. Uh, any questions or any doubt? You can use the chat box, and we are ending this session. If you have any doubt, you can use my email ID also. You can email me. Okay, I'm stopping the recording. Thank you.